So again, good afternoon to our speakers, Regine Stein and Gabriele Taentzer, but also a warm welcome to the audience here in Zoom and on YouTube. I'm very happy for having Regine Stein and Gabriele Taentzer as our speakers for today's talk, How to Define the Quality of Data and Data Models, a perspective from the cultural heritage domain. And Regine Stein is head of the Research Infrastructures program at the Göttingen State and University Library, and she has been involved in standardization work on the documentation of cultural heritage at the German and the international level for more than 2 decades. And she also played a leading role in the development and implementation of the standards for lightweight information describing objects, LIDO. In the NFDI consortia, NFDI for Culture and Text Plus, she works on cross-cutting issues such as metadata, terminologies, and data quality. Furthermore, she is also a co-spokesperson of Text Plus and Base for NFDI. Gabriele Taentzer is professor at Philipps University Marburg, where she heads the software engineering research group. Her research interests include data and software quality assurance and model-driven software engineering. She is one of the leaders of the KONDA project on continuous quality management of dynamic research data on objects of material culture using the before-mentioned LIDO standard. In this project, she has started to transfer the model-driven engineering approach from software to data. And I want to give you a short glimpse on what the talk is about. As you all know, data quality is a much discussed topic, not only within NFDI, but like everywhere where data management plays a role. And it is of great importance for data management. However, the definitions of quality dimensions are not as clear as we could expect. So the definitions vary widely. And we can call ourselves lucky that Regine Stein and Gabriele Taentzer have run the KONDA project and will present the results of this project in today's talk. As one part of the project was to analyze the existing quality definitions for data and data models with a main interest in semi-structured linked data. And so they will give us an impression of the results of the project on this analysis. Afterwards, they will present a test case for applying a fast-track approach for FDOs in the health domain. And last but not least, the road ahead will be discussed in today's talk. And now I want to hand over to our speakers.
Yeah, thank you very much for this kind introduction. And as you said already, we present here some results of our KONDA project, actually core results of our project. And yeah, looking back into the series of these talks here, there was one talk nearly 1 year ago by Carsten Schmidt from NFDA for Health. And it was also about data quality. And we tie in with this talk now from the perspective of cultural heritage. Yeah, when looking into the news, there are many contributions about AI nowadays. Yeah? And AI is a big game changer these days. And but AI is nothing without data, and the data has to be good. So, and here we come to data quality. And the central question of this talk is how to define data quality. And the NFDI aims to enable systematic management for valuable data from science and research. And data quality is also of central importance in the NFDI. Yeah. So the outline of our talk is the following. So to have a the basis, we first talk about what kind of data we are considering. Then there's a main question of our talk, how to define data quality. And thereafter, we look at quality problems in the cultural heritage domain and try to draw a connection to the definition of data quality. And thereafter, we also look at data model quality and how to define it. And then head over to application profiles and how to ensure data quality, and especially how to analyze data quality. So let's start. Yeah, what data are we talking about? And actually, we are talking about structured, semi-structured, and unstructured data. They all occur in some way in the domain of cultural heritage. And we focus here on semi-structured data and follow the definition by Abiteboul, saying that semi-structured data is neither raw data nor strictly typed data, but somewhere in between. Yeah. You see some examples here on the slide for structured data, semi-structured, and also unstructured data. And we focus, as I said, we focus on semi-structured data, usually or often given in XML. And we also consider linked data, which allows to connect between different data sources. Yeah. And this semi-structured data may or may not have a data model. If they have a data model, it is used as graphical or lexical representation of data, specifying their properties, structure, and interrelationships. And for representing a domain, a conceptual data model is a data model that represents an abstract view of the real world. On the right, you see an example of a data model, actually, a very small one. Yeah. It's of cultural heritage, and you see the main domain elements like place, person, organization, and different kinds of cultural objects like paintings, building, print sheet, and so on. And this example is given as a schema definition in XML. Cultural objects often also have metadata that describe, for example, the format of a painting or its provenance. So data about its origin. Yeah. And so metadata describes data. And here's an example of a metadata in LIDO. LIDO stands for Lightweight Information Describing Objects, and it is a data model for exchanging and harvesting metadata about museum and collection objects. And the example you see here in the middle, this metadata describes how objects are measured. And for example, a painting as a one given by Picasso. So having clarified the kind of data we are dealing with, we come now to the main question of the talk. And this question is how to define data quality. And this question has been asked again and again in science. And many publications appeared in the last decades. So you see here the first one appearing in 1985 and the last one last year. Yeah. And we have done a systematic literature review, and these 39 publications you see here we have considered those in more detail. And what we have found is that the definitions of data quality differ considerably. So how to define data quality? And actually, when you think about data quality, you might come up with a lot of different aspects as they pop up here. Yeah. So data should be accurate and consistent and precise and compact and so on and so on. Mm-hmm. So what we have seen in the literature is that different kinds of quality dimensions have been defined. And actually, also following the ISO standard on data quality, these dimensions are distinguished into two groups. Actually, internal dimensions and contextual dimensions. So internal dimensions means the internal quality of data, or the inherent quality of data. And often these are the dimensions accuracy, completeness, conciseness, and consistency. Contextual dimensions are those that consider data in the context of other data or data in time, or also people and tools working with data, so towards understandability. And the dimensions are defined very differently in the literature, and even when they are named alike. To compare the quality definitions in the literature more precisely, we have taken a feature-based approach. So we identified quality features for each dimension. So now I come to the quality features we identified. And I go through the dimensions step by step and start with the internal dimensions. So for accuracy, we could distinguish syntactic and semantic accuracy, also external accuracy concerning external links, compliance with respect to rules, and also precision with respect to the data values. Completeness is distinguished into internal completeness and external completeness. Internal completeness inside of a data set, external with respect to other data sets. Conciseness refers to relevance of data and compactness of data. Consistency refers to logical consistency, so no contradictions. And coherence of data with respect to format and also meaning. Coming now to contextual dimensions, there's accessibility. This means the data should be available for authorized users. Currency means the changes of a data set in response to changing information. And the features we could distinguish there are data currency. This refers to how up-to-date data is. Then data update currency refers to the degree to which a data set is updated promptly after a domain information has changed. And time concurrency refers to data where all elements of a data set are updated at the same point of time. And plausibility, this refers to the credibility of data, which is very important, especially in cultural heritage. And this is either based on provenance of data or due to trustworthy people. Traceability distinguishes temporal and causal traceability and means the availability of information about data changes over time. And understandability refers to the ease with which data can be processed by users. Users may be people or tools. In the following, we focus on some of these dimensions, not all, because we do not have so much time. And we took those that are most interesting for cultural heritage. And yeah, so we will focus on accuracy, completeness, plausibility, and traceability. So let's start with data accuracy. This is a dimension that is mentioned very often in literature, and it includes syntactic, semantic, external accuracy, and also compliance and precision. So I start with syntactic accuracy. It refers to the degree to which a data set conforms to the syntax of a data description language used and any data model that may be present. So as I said in the beginning, we are focusing on semi-structured data and looking, for example, at an example to be syntactically correct. Lido data in the cultural heritage context should conform to the XML data description language and the Lido data model. Yeah, so to get an idea what syntactic accuracy could mean. Going over to semantic accuracy, it refers to the degree to which a data set correctly represents information of the domain of interest. And here the domain of interest is an interesting concept. It is not always the whole domain of, for example, or the wide domain of cultural heritage here in our example or in our perspective, but can also be a smaller domain. For example, for example, a registry or some collection of paintings or things like that. Yeah. The example here is the Mona Lisa, is a painting by Leonardo da Vinci. It would be semantically inaccurate to attribute the artist Pablo Picasso to the painting. Yeah. External accuracy refers to the degree to which all interlinks in a data set are valid and point to the correct data elements in other data sets. And a place of birth, for example, may be indicated by a name, which should ideally be accompanied by a link to a location register. This link should be valid and thus correctly retrievable. Yeah. So external accuracy is usually about these interlinks. Compliance refers to the degree to which the dataset conforms to rules and guidelines established for the data description language and any data model being used. Example here is the internationally recognized ISO standard that specifies dates that should be in a certain format. So first the years and months and day. Precision, the last feature of accuracy. Precision of a data set refers to the degree of exactness of all contained data values that is appropriate in the particular context of use. And I think the example shows different contexts of use. So different objects may require measurements with different precisions to designate the Burj Khalifa as the tallest building in the world. The unit of measurement of the height of the building in total meters is sufficient, provided that a list of all buildings is available. In contrast, it is common to specify the precise dimensions of a print sheet in millimeters. Yeah. So you see here two different contexts of use, and according to these, also different ideas about the precision of data values. Now I go over to data completeness. Starting with internal completeness, it refers to the degree to which a data set contains all data elements of the domain of interest required for a particular context of use. And each of those data elements defines all the properties and links required for that context of use. An example here, in the register of paintings, all the registered paintings of a selected artist are needed to create a chronological overview of that artist's work. Yeah, completeness is often very difficult to cover, and but once we have a limit or a border, then we can, give a quality requirement, so to say. External completeness refers to the degree to which a data set contains interlinks to other data sets that are required for a particular context of use. For example, to prevent misunderstandings, each place of birth should be indicated by a valid link to a specific location register, such as Wikidata. So now I go over to data plausibility. Provenance refers to the degree to which a data set and the data elements and data values it contains are equipped with verifiable information about its origin. This is very important in cultural heritage. For example, references for the date of death, such as a death certificate, can verify the information and increase its plausibility. Trustworthiness refers to the degree to which a data set and the data elements and data values it contains are believed by a significant set of people with respect to a particular context of use. And for example, a person's education, experience, and reputation increase their trustworthiness. Cultural heritage information published by a renowned museum about an object in its possession is more trustworthy than information in tourist promotional material, because the museum is trusted to have relevant expertise and to handle this information responsibly. Due to lack of time, I skip the traceability and go over to the next topic here. And so to empirically evaluate our feature-based definition of data quality, we collected a set of quality problems in the cultural heritage domain and mapped them to the features. The set of problems collected has been put into a catalog, and the set is very large. So here you get an impression. I start with some quality problems about missing data, missing sources, and so on, or heterogeneous structures, heterogeneous precision of data. It goes over to misspelling, wrong information, misplaced information, multiple data records describing the same entity, redundancies. And you see the font is smaller and smaller. Yeah. And there are even more quality problems. I like to take out one of these, missing reference to authority data. What does it mean? You see here an example. Here, an actor has just an identifier. This is what is shown in the first line of the example. Instead of an external link to an authority, such as the integrated authority file provided by the German National Library. This is what you see in the lower two lines, in the lower two lines of the example. And the problem here is that the primary feature, which is external completeness, is affected because the external link is missing in the upper example. And a further problem might be appropriateness, since it remains unclear where the identifier comes from. So this is just one concrete example how quality problems that we collected from the community in workshops and in interviews can affect certain quality features. And we showed with this catalog that all identified features are useful to classify the quality problems, and that they are also sufficient for classification. So since a number of data problems even have their causes in data models used, we also investigated the quality of data models. And also here we conducted a literature review with publications on data model quality, on model quality in general, and on quality of conceptual models. So quite wide, I would say. And we were able to adapt the feature-based quality definition for data quality to data model quality. And the reason is that a data model is also data. Yeah, so it's a special kind of data. And so we have, we can come up with the same quality dimensions as for data. And so you see here again the internal and the contextual dimensions, and can ask questions such as how accurate and how complete is the domain of interest modeled. So this refers to the internal dimensions. And actually in the literature, we have found that the internal dimensions are usually considered for data models. But we can also ask, is a model accessible, or is it current or plausible, and so on, and even understandable. Yeah. So also the contextual dimensions make sense, but they are actually new. So we propose to consider also contextual dimensions for data model quality, as since data models are, as we said, special kind of data, and it makes sense. Now I hand over to Regine, to show an example of data model.
Thank you, Gabi. Yes, so I will continue and dive a bit into an example of quality assurance for data and data models from the cultural heritage domain, which is of specific relevance for the communities of NFDI for culture, but I hope also beyond. So our example here for a widely used data model in the cultural heritage domain is Lido. Gabi mentioned it already several times. It was developed under the auspices of the documentation committee SIDOC of the International Council of Museums, ICOM. And next, Gabi, Lido is an XML schema for sharing metadata in repositories and online services. It is based on SIDOC CRM, which might be well known to some of you here. SIDOC CRM has become an ISO standard since 2006 and is a conceptual reference model that is a domain ontology for the cultural heritage domain, and as such widely used in the context of research data on cultural heritage. It is per se not a data model. Now Lido defines an explicit format for providing object information in a standardized form, and it is intended to present the full range of descriptive information about objects of material culture, such as from art, cultural technology, and natural sciences. In the light of our project, of our KONDA project, so in the light of quality management and quality assurance of dynamic research data on objects of material culture, the further development of Lido was actually part of the KONDA project and is now ongoing within NFDI for culture. Lido was actually developed 15 years ago as a domain-specific response to Dublin Core, which turned out to be too generic to describe museum and collection objects. However, when it comes, for example, to genre-specific questions, obviously Lido is still a quite generic schema. And to give an example, for a painting or sculpture, it is typically required to give some information about the artist who created the artwork, and if it is the information that the creator is unknown. But for natural history objects, such as a mineral, there can't be a creator assigned mandatorily, since it is not a man-made object. Therefore, in Lido, only 3 elements are mandatory, so as to allow for such different requirements for objects of material culture in general. However, it might be useful to add such kind of requirements to the schema for specific use cases, like for describing paintings and sculptures. So let's discuss a bit the concept. Next, Gabi. The concept of application profiles and how can they be used to ensure data quality. Next, please. One approach to assure or improve data quality according to the various quality dimensions Gabi presented is to develop specific data models for specific use cases within one domain. That is ideally providing application profiles which are based on originally more generic standard data models. And defining application profiles is a well-established technique. Many of you will know it. It's a technique to adapt or also combine existing standards, again, data models, in order to fulfill specific requirements and to achieve at the same time interoperability with those standards and facilitate reuse of the data. So an application profile implements specific requirements for a given use case. It always conforms to the schema or schemata on which it builds. The application profiles thus ensure and improve data quality during data production and are also often used for data integration. And in addition, we consider here a framework for the development of application profiles, which will ensure the quality of these profiles themselves, thus addresses data model quality. So let's look into profiles. Lido profiles are connected with specific use cases and may consist of further mandatory elements than in the original schema. Mandatory, if available, recommendations, which are validated through schematron rules in our context here, restrictions, which elements of the schema to use, terminology recommendations, and extensions of the already provided Lido terminology. In the Lido context, they always have to be compliant with the generic Lido schema. So what are examples for additional requirements that we know already? Here in the profile for paintings and sculptures, we have, for example, information about the repository required, and that is the institution of custody and where the object is located. We have information required about the materials used and techniques applied for the creation of the object. We have information about at least one event from the object's history required, and we have extensive terminology recommendations included. For example, to the Art and Architecture thesaurus, which is available as linked open data. So next, please, this genre-specific Lido profile for cataloging and publication of metadata describing paintings and sculptures is developed or was developed in the KONDA project by the German Documentation Center for Art History, Bildarchiv Fotomarburg, and we provide a handbook. You find here the DOI and an XSD. But there are also other Lido profiles under development. For example, from the CIDOC community, the EODEM profile is also a Lido profile and defines an exhibition object data exchange model. Now, next slide, please. In addition to working on these profiles, we are currently working on a workflow to support the development of such profiles in a systematic way. The aim is, on one hand, to simplify the definition of profiles for domain experts who are not familiar with technologies such as XML schema. And on the other hand, we want to provide a means to support comparable structures of such profiles and to monitor their quality. So if you encounter the need to develop your own Lido profile definition, You can do so based on the template here in TI syntax, and the XSD, so an XML schema, including schematron rules, will automatically be generated by an XSL transformation. Step 2, which is still work in progress, next please, is now currently to generate as well an HTML documentation of that profile, and also to define an XSD which validates the actual profile definition. Next, please. So application profiles are a quality assurance technique used when compiling data, and of course there are also analysis techniques for data quality on which we also worked during the KONDA project. Next, please. A very common approach are standard checks. For example, finding duplicates in a data set to ensure freedom of redundancy. Another approach is the checking of metrics to ensure completeness, to ensure property completeness, and measuring the number of values that are not null or the actual number of values. And within the KONDA project, we have examined two methods. That is first the validation of patterns. Here, for example, to ensure compliance, you can specify patterns for data values of a certain type, obviously date specifications or specifications of measured values. And another approach is the clustering of heterogeneous data values. To ensure coherence, you would find bottom-up inconsistencies in your data. So to wrap up here, how can domain knowledge be included in data quality analysis? The one approach is top-down, quite typical. That is configuring analysis with domain knowledge. And the other approach, as we did with the clustering approach here, is bottom-up, learning new domain knowledge from data. And to conclude, next slide. Data quality is a complex concept which is still and continuously evolving. We have used a feature-oriented analysis here to review the various existing quality definitions. And our focus here are semi-structured linked data. Our feature-oriented approach led us to substantiated and partly new definitions of data quality and data model quality. And these definitions were evaluated through an empirical study of quality problems as they occur in the cultural heritage domain. Application profiles now are a widely used technique to avoid data quality problems in the first place. We have developed it for the Lido data model, and they can, of course, be naturally combined with analysis techniques for data quality. Coming soon is the publication on this work, how to define the quality of data and data models, a feature-based literature survey, and we consider this paper a contribution to an NFDI-wide understanding of data quality and data model quality, while our work on the application profiles and the related workflow I presented are a more specific contribution to NFDI for culture. But of course, the approach is also transferable. We list some literature here at the end. And thank you for your attention. And we look forward to a vivid discussion.
Thank you to our speakers and to the audience in Zoom and on YouTube. And we will be happy if you join us for our next talks. So please have a look on our website for the upcoming events, either on YouTube or live on site. And now we can continue.